Hi everyone. My name is Dattaraj Rao. I'm a chief data scientist at Persistent. I head the AI research team here, working on some cutting edge technologies around MLOps, knowledge platforms, responsible AI, and next best action. How I like my coffee. I'm based in Goa, India, and I love my traditional Indian, South Indian style filter coffee, super strong, and I will take that over any cappuccino. So that's how I like my coffee.
What is up, listeners? This is another edition of the MLOps Community Podcast. I am Demetrios Brinkman, and today I am joined by none other than Mr. Vishnu Rachakanda.
Nice. Very good job pronouncing that, Demetrius. Over the course of our friendship, over the course of the 2 years Demetrius and I have been doing this, because I think now we've just hit the 2-year mark, that Demetrius got a lot better at that pronunciation. It started off Rachakanda, then it went to Rachakanda, and now it's
Racha
pretty good.
Wacha. Man,
Yeah.
it's not the easiest last name, but
No.
I can empathize because I do not have the easiest name either. So I feel it for you. Anyway, today we're not here to talk about last names. We are here to talk about machine learning operations. And
As
we
always.
had none other than Dattaraj on the podcast. I'm super stoked about this because he's one of those guys that I feel like I'm just going to pat myself on the back. It was an incredible find on my part. Although there's probably a ton of people that know about him already because he has written a book and he's written one of the OG MLOps books, and we talk about it in the podcast. But since then, he hasn't written more books, and I just saw him on, I think it was a Medium post, or I saw the book. I may have been getting into his book, and I was like, dude, we got to get this guy on the podcast. Because as we mentioned so many times in this podcast, the book is incredible because the principles that he presents are everlasting. It's not one of those books that you read and then a year later, as technology continues to advance, it no longer is valuable. It is a book that you can keep on your shelf and refer back to it because of those principles. And you see the way that he thinks. It's like that. I mean, I don't know about you.
Yeah. Dattaraj Rao, just to give you guys a little bit of context here, he is actually the chief data scientist at Persistent Systems, which is a IT services and software engineering services provider based out of India. And prior to working at Persistent, he spent close to 20 years working in a number of different technology leadership roles at GE, including in their research division, their power division, their transportation division. And I thought that what he brought was such a great um, engineering mindset to this podcast, to this conversation, to the machine learning problem space. And you can see that in how he structures his answers, how he structured the book. Very structured thinker, which I always appreciate. It helps with the communication, and it helps with actually figuring out what the insight is that people are offering. And I give you credit, Demetrius. This was a great find and a great podcast.
Well, thank you very much. Dude, one thing that I'm a little bit bummed we didn't even get into is he has 11 patents around computer vision, and we didn't even get to talk to that at all. I mean, we were so enthralled with all the other cool MLOps stuff that he's been getting into. The video analytics work that he's doing right now and 11 patents that he's got going on. It's incredible. So
For
the
sure.
dude
Yeah.
is a G.
Yeah, I think, my favorite part of the podcast, which you guys will hear more about, are the 3 top areas that he's super interested in when it comes to machine learning, what he sees as up and coming, what he's investing his time and his company's time into. I think that was great to talk about and think a bit bigger about. What about you, Demetrius? What was your favorite part?
I like the end when he talks about the patterns and oh no,
Yeah.
actually, you know what? I mean, along those lines, it was kind of the same thread, but when he talked about how he was going from rule-based systems and you would deploy rule-based systems into a system, systems, and more systems. And then when he made the jump into machine learning systems or machine learning models that you would deploy into systems and how those are effectively the same thing. It's just now this machine learning model is much smarter. But you can look at everything that goes around deploying a rule-based system or a machine learning model into a system, and just like stop me if I say systems too much. But the idea around that and how he just really broke down the patterns that are still the same and that you can hold on to and you should be thinking about whether you're doing rule-based or machine learning. I thought that was awesome. And that was probably my favorite.
Yeah, great conversation. Let's get into it.
Let's do it. Before we do, I want to mention that this podcast is brought to you by none other than Superwise. They are a machine learning monitoring tool and they are killing it. I have had the opportunity to meet the whole Superwise team. They sponsor the podcast. They are what you need if you are looking for machine learning monitoring on any level, at any scale. You can check out some of the episodes that we have done with the founders. We'll leave that in the show notes if you want to dive deeper and you just so happen to be looking for some machine learning monitoring tools right now. Check out superwise.ai to get all of your monitoring needs met. Now let's go into it. Dattaraj, it's great to have you on this podcast, man. I'm very excited to talk with you.
Yeah, likewise. Thanks, Dimitrios. Thanks, Vishnu.
So, you've got a pretty incredible background. You've been in the game, as we could say, for like over 25 years, I think. And you studied mechanical engineering at school, and then you went on to pursue this software engineering at General Electric, working on developing monitoring systems for rotating machinery. Can you give us like just that thread? What drives you? What brought you through the last 25 years?
Yeah, it's 24 actually, but
All
yeah,
right.
it's a
We
long
can
time.
round up, man. It's all good.
But yeah, so I started off like you said, I'm a mechanical engineer from Goa, India. Here, that's where I live now also. So I moved back to my hometown where I studied. And what I mean, engineering always fascinated me. I guess I always wanted to be an engineer. And to be honest, I didn't in the academics. I didn't get through computer science, so I was always missing out on that. So that was something that I kind of self-learned. Even while doing my mechanical engineering, I was picking up learning new stuff in computer vision and in computer science. Sorry, and then I think what really worked is that just continuous things to learn. So over the 24 years, 25 years, I think what has really stuck with me, what is driving me is the fact that I can learn new things. I get scared that one day I'll wake up and I won't be able to learn new things. So I mean that's something that scares me. Every morning I just, whether it's a podcast or reading something on Pocket or Kindle book, I just kind of pick up things, and that's what I like to do. If you follow me on LinkedIn, I'm like sharing things almost every day, 3 or 4 posts. Just something somebody has done, some interesting model that has come in the market on an NLP or something around MLOps. A lot of great content recently on MLOps, including your fantastic podcast. So I think
We do
I
what we
really,
can.
yeah, some plug there. But yeah, I think that's what really drives me. So after my education in mechanical engineering, I really wanted to do something fun in computers because I really was not into a classical formula based system. So I got into numerical methods. I built like a finite element website. So started with Fortran, then because Fortran was the only language to learn at that time. This was like in 98, 97, and then Java was just coming up. Sun Microsystem had released Java, I think 2.0 at that time. So I just picked up Java because the interface was nice. So my thing on Java was not about cross-platform, server-side, nothing. I just wanted my code to look pretty on the screen because Java had some fancy charts which Fortran didn't. And then that's what I did. I built like a website. At that time, there was something called Java Applet, which was the next big thing. I mean, some of you may not even remember, but these
Nope.
applet was like the web browser was running applets in the web browser was the thing at that time in the 2000s, and that's what I did. I built a website with Java-based FEM software for numerical analysis and calculating stress on models. So and that was very, in fact, that's the thing that got me the job in GE. So GE was trying to do something similar. They were building design software, and I got my first job in Bangalore. I moved to Bangalore from Goa and worked there for 4 years building design software. And then within GE, I got another opportunity. I wanted to move out, explore the world a bit. So I moved to the US. I moved to Norfolk, Virginia, and spent like 9 years there. And there we were I was working with GE Power there, and we built some remote monitoring software for gas turbines. That's the rotating equipment. So this was actually an acquisition by GE Power. They had a very nice novel software for capturing any anomalies that happened on machines. You could define rules saying that if some thresholds are violated, flag some alerts. And they used to use concepts like even no ML yet. It was purely rule based. It was fuzzy logic, a lot of cool stuff, but very deterministic. And then slowly we started at G Power getting into neural networks. Neural networks were very big at that time. I mean, plain vanilla neural networks, your MLPs. So that we started getting into that, and then back in 2013, I wanted to move back to my hometown, or actually move back to India. So I got another job through GE at GE Transportation, and I moved back to Bangalore. And then at Bangalore, we worked some very interesting work in computer vision. So that was my first official foray into machine learning, where we built really interesting computer vision models, OpenCV based stuff, a lot of very new computer vision stuff at that time. I mean, some of this object detection, etc., and which became very popular. I actually got like around 11 patents in that domain, where we actually had a product which could, which had a camera mounted on a locomotive, and from that camera we would monitor the railway track and find anomalies. So that became very popular, and that was one of I will say highlights of my career. And then after that, like 4 years back, I wanted to move back to my hometown and got this amazing job at Persistent as a chief data scientist. So this was something that I really wanted to move back to hometown. It was a very high position, and I'm actually now at Persistent running the AI lab for them. And this is like I have some really smart data scientists working for me. We have some really niche areas that we work on, like federated learning, responsible AI, a lot of work in MLOps, knowledge graphs, next gen NLP systems. So we get to do a lot of cool work. So yeah, that's where I am today, and enjoying the but still learning. So I get to wake up in the morning,
Yeah.
learn new stuff. So I definitely something I enjoy.
Awesome, awesome. Yeah, no, thank you for taking us through that. That was illuminating to hear, where you started and all the experiences you gathered along the way and where you are now. And where I'd love to dive in is there, is your work at Persistent, what you're interested in right now. I was taking a look at your LinkedIn. You clearly just wrote a book in Keras to K, Kubernetes. I see the thirst to learn and the drive to the curiosity in you. And I'm kind of curious from your perch at as a chief data scientist at Persistent, what are the top 3 areas of machine learning that you're most interested in? I've seen you share things about large language models. I've seen you share things about responsible AI, MLOps, other sorts of modeling techniques, bioinformatics methods, all kinds of stuff. Like, what are your top 3 areas that you're most interested in and that you're championing work on at Persistent?
Yeah, that's a very good question, Vishnu. So I would say the top three areas definitely will start with knowledge platforms and knowledge graphs. So definitely we do a lot of work on large language models, but one of the and Persistent, we are like a technology services company. Like we are $1 billion company now. We make and a lot of our work is for banking and financial sector and healthcare. So those are the most of our customers, two major customers. We do some work for industrial also and ISVs, but BFSI and and healthcare are two prime. And a lot of these areas, just large language models don't fit the cut. We do need to capture the context. So capturing context, extracting entities, capturing the relations. So knowledge platform becomes very important. You need to be able to explain why you are providing certain recommendation or why you are giving a search result. So explainability of this large language models using a knowledge graph, I think that is one area, and I wouldn't say we have it figured, but we have some very interesting offerings that tackle this. So that will be one. Second area is definitely around responsible AI. MLOps is something we are doing, but we tend to get more into interpretability and explainability of ML models. Again, our banking and healthcare customers, we are in a very regulatory environment. We have to prove why a particular loan was approved or no, or why a particular diagnosis was provided to a patient. So interpretability, explainability becomes very important. And then one of the things that really a lot of customers, I see not enough customers spend time, is to understand the ecosystem in production, how the data drifts, how the concept drifts. So that is one area of MLOps I see a lot of gap, and that is another thing that we heavily promote at Persistent to help our customers to understand the dynamics of the data. And then the third area I would say would be something around privacy preserving AI. Again, it kind of falls under responsible AI, but that is one area we see is going to grow heavily, because like they say, AI is the new electricity and data is the new oil. But you're seeing cases where people are getting sued for not using data with consent. So especially in the healthcare space, we don't have access to data. We have very dummy data in the public repositories on which we are supposed to build models. So we really see something like federated learning or confidential computing can really help solve that problem. Keep the data private and use only the right insights, and only use the data with right governance models. So I think to give a long answer to you, Vishnu, definitely knowledge graphs, MLOps, responsible AI, and privacy preserving AI. These three areas I would say are our top focus areas in persistent research, and definitely on my top list.
That was extremely illuminating to hear. Thank you for sharing all that. I always like to ask our guests what kinds of things they're interested in, what kind of things are animating them, and I want to dive deeper into one particular point, which is you talked a lot about how large language models, while they're interesting, may not necessarily be sufficient for a task because of the context that's required. I'm personally I'm very interested in diving deeper into that point, because we're really seeing LLMs have a huge moment right now. I mean, the interest is very high, and we're seeing a lot of discussion around that in our community. And so I was wondering if you could give an example of a use case where an LLM was not a good application for the natural language sort of task that you might have used. And I understand that certain things are confidential, and you can't share the total details, but even a toy example, it would be very helpful to understand that more.
Yeah, that's a good point. And but by no means I'm saying that LLMs are not effective or powerful. They are
Totally,
definitely
totally.
amazing. Uh, so the thing so typically some of the traditional use cases for LLM, like question answering or your summarization. So we saw some, like one of the examples we had was this text research. Okay, one of the customers was looking at texts and documents on the internet, and like text bulletin is published, and then you would want to query that text where this is the, like, Virginia state tax or some GST. So if there is a text update, how would you extract that information? So we started with LLMs, and we could ask some questions. We could extract the text, process. I mean, we started with a pre-trained model, fine-tuned it on some existing corpus that we had scraped from the net, and then we built a question answering system which was pretty good. It was giving the relevant answers, but we could not justify, because everything is, as you know, LLMs is the whole idea is they convert your raw text into embeddings, and then that embeddings is what is used to find a matching, semantically matching sentence or a paragraph. So we could find the right answers, but we could not justify like how it would be like a text rule. So in that use case, what really worked for us would be we wanted to extract specific entities, like which county had how much percent tax, and what was the imposition type. So these specific entities, I would say, related to the text domain. So we changed the problem to a NER problem. So we had specific entities that we extract. We had some relationships that we extract. And then the key thing was building a knowledge graph. So a knowledge graph would then start relating these entities and to each other. So if Gloucester County was an entity, 6.5% was a numerical entity, and then say goods tax was a imposition type. So saying that Gloucester County from this particular date, from 2006, the sales tax would rise to 6%. That became a knowledge that we will store in the knowledge graph. So this particular fact, now we could keep it as a sentence as an LLM and do a matching. But as you can see, a knowledge graph, because we are showing this as relations, it gets very complex. Now I can do queries like, tell me all counties who have greater than 6% sales tax since 2016. So now you get the structure of your data, you get a semantics of the data, and that
Right.
becomes very important. So
So
some of these queries, just to answer
no,
the
keep going. Yeah, yeah.
specific question, you could answer to the point questions using LLM, but using a knowledge graph, you can do much more. You can explore the space better and make it more explainable. That's what we saw. This was just one example.
I think that's a great example. I think it's very it neatly summarizes how it really depends on the task, right? It depends on the task at hand. And then based on the problem, you design the solution. And I think that's an
Exactly.
obvious statement to make, but sometimes, particularly as practitioners of a particular art or a particular technology, we get excited about the potential of the technology without necessarily considering exactly what kinds of problems it's best suited to solve. And it seems that what you're kind of saying is, for certain tasks where exploring a space with particular constraints or with a particular structure is important, a tried and true approach of named entity recognition and sort of mapping the knowledge and structuring the knowledge that way is better than sort of the ostensibly more powerful but a little bit less clear method of like a large language model. And this is just one example. Of course, there are plenty
Yeah.
of cases where LLMs are useful for sorting through much larger spaces of data where you may not have as much a priori understanding of like what kinds of entities are important and what things what relationships you want to identify. It sounds like so. Am I summarizing this correctly?
Yeah, absolutely. You summarized it well. Definitely.
So is this something that you feel like will change in the future, or is that just an inherent problem with LLMs?
Well, I don't see this as a problem. I see the problem with the hype of LLMs. Like I think people are saying LLM is like the next best thing after sliced bread, and they are throwing LLMs as solving everything. So in a real world, I think we just need to like Vishnu correctly said, it depends on the problem. Like some problems like a pure question answering solution, even conversational AI, I think LLMs are doing a fantastic job, and they can do really well. But if you are going to get into the knowledge path, you want to extract knowledge, structure the knowledge, and answer questions with giving concrete evidence. And again, knowledge graph is not like a competing technology. You use LLMs. Even NER, today the best NER techniques are based on LLMs. I mean, transformers have beaten most of the benchmarks for NER. So you use LLMs but then you to extract knowledge, not just blindly use LLM to solve any problem. So I think that's the main difference. I see the LLM with a context-based knowledge graph growing as an application area rather than just pure LLM. This thing.
Yeah, I see that. I see that. Cool. So then, um, let's keep cruising, because there is something that I know both of us wanted to talk about, and you mentioned it for a second when you were giving a bit of your background. It's around the remote monitoring and diagnostics. Sorry, and you said something before we hit record that is cool, and I wanted to bring back into this conversation right now, which was around how the ideas didn't really change. Like, you find yourself doing the same thing with different technology. In the beginning, you were using a very rule-based system, and then you transitioned to now a machine learning-based system, but there's still some fundamentals that didn't change there. And can you give us what exactly it was that didn't change?
Yeah, and that example was more around like in when I was doing remote monitoring and diagnostics. The idea was you would at that time they would be called domain expert or like engineering experts who would compile certain rules. So rules would be something like uh, if the input temperature exceeds so much value, at this particular notch, you may have an alert. So change the operation. So as simple as a simple instruction checking for thresholds. So they would write this rule. So this was a domain knowledge in the mind of an expert, and you would capture that knowledge as a rule, package it as a rule, and send it to a system where this rule inference would happen, and the rule would run, and the rule would trigger on the real machine whenever the temperature crossed the threshold, and you'll get an alarm back. So that was basically, in a nutshell. I mean, reality is much more complex, but a simple example, that would be how a remote monitoring and diagnostic system would run. You would send rules, package them for a particular device. Like in this case, device could be a turbine, and you would get an alert back whenever certain rules would be violated, so that it was information for the end user to do something. Now with ML and with MLOps, in a way, the way I look at it, you're pretty much doing the same thing. You are have a development environment where you are, instead of writing rules, you have some training data that you're pulling. You're building a model using some GPUs, or or maybe even some low code ML tools like AutoML. You build a model. Once you're happy with the model, you test it on your training and test and validation data. If when you're happy with your precision recall, now that model becomes like your, like, equivalent to a rule. You send it to a machine. Now this could be in the cloud, or it could be an edge device, and now that model will run continuously on live data, and it will again trigger alerts whenever certain thresholds internally would. Now this model is much smarter. Now in the rule case, the domain expert need to figure everything out, like what should be the temperature that should change. But now this ML model has been trained on a lot more data. It has seen, probably the way I would say it, it has seen the world more, because you're given it so many examples of real world
I
data.
like this.
So this is a very, it's equivalent to that domain person writing those rules manually. So all you have changed it, instead of some domain person writing rules, you have given it data and made it learn. But the ops part remains the same. You're sending the rule out, the inference is happening, and you're getting alerts whenever the rule change. Now the only difference, so that is the same part.
So that is awesome.
Yeah.
I understand what you're saying. If I can just reiterate that back to make sure that I am hearing you clearly, it's that instead of having to figure out 100 or 200 or 200,000 rules and hard code them into the system, you deploy the model, and that is going to figure out the rules, and it's going to be much smarter than all of these hard coded rules, because it's going to be able to understand the data and interpret the data in a way that these hard coded rules wouldn't have been able to.
Exactly. Yep. That's an excellent summarization. So and then just to add to that, so what remains same is the way that you're sending this I will just call it intelligence. It could be rule, it could be ML model. You're sending this packet of intelligence to an edge device, making it to inference, and getting some insights back as an alert. Now, what remains same is this communication mechanism to send it and invoke it. Also, what remains same is a lot of other things. If you think about it, things like bias, like just like an ML model may be biased on certain factors. Now, if that guy building that rules says, hey, if that gas turbine is in this country, is in one of these countries, I don't want it to fire beyond this temperature. So that is a bias that that person is intentionally adding to the system. Now my model may be adding this bias. Now I just want to check if those bias are not right. So if he is adding some unwanted bias, and I can't think of a good example, but if there is a bias which is not supposed to be right, I wouldn't want the human to be adding that as a rule, nor would I want my ML model to learn that from the data. So the fairness checks, the explainability, all becomes relevant. It is just that it's a different time. The model is different, but all the infrastructure deployment, all the MLOps pieces, same thing with drift. I mean, the data is going to change in production. Tomorrow, that turbine is going to wear over time. So after another 1 year, there'll be a lot of degradation in the turbine. You will want to change that rule. So you would want to check for that drift. In this case, it's a physical drift. Similarly, you want to collect new data and retain the ML model. So in my experience, I mean, though we didn't call it ML at that time, the infrastructure and the rule deployment, the intelligence deployment remains same. It's just ML ops is because it is ML. So it's very interesting that there are a lot of similarities and differences to this.
Totally. Yeah, I think the way that you the way that you summarized how to think about intelligent systems, right, and how to, ship those kinds of systems, and what kinds of of features are the same and different as the kinds of intelligence that we're working to embed into systems has changed is awesome, and it's very helpful. It goes very much to the heart of what it is that we are trying to do with machine learning, right? Which is bake some kind of intelligence in a way that's right now very difficult, but we hope someday through our work and the industry's work will be very easy, into the operation of products. And I want to use that sort of fundamental set of observations that you've offered as a way for us to start talking about your book. You released a book recently with O'Reilly called Keras to Kubernetes. And it's, I love the title, sticking with the
Thanks.
Ks. And I want to start first by asking you, what is it that compelled you to write this book, and what's in it? And can you give our listeners a little bit of the story of how you got to it?
Yeah, and first of all, thanks for asking about the book. I somehow miss that in mind. I often tend to do that. I tend to miss out on it. I
You're a
don't know
very
how.
prolific person. There's a lot to
Thank you.
cover. You a little
Yeah,
bit
it
like
probably
my
only
friend
took a few
Patriots.
years of your life, so
Thank you so
a
much.
few out of those 24.
You have a lot to talk about. So yeah, I'd love to
Yeah.
hear about it.
Yeah, to be honest, writing a book was something that was always on my bucket list. I mean, that's something and just like learning on LinkedIn I really like sharing my things. So even a lot of my colleagues would also vouch for it. I love to share my experience. If there is a new technology I learned, I would love to share that. Even on LinkedIn, tend to put a lot of these kind of posts to share information. So I really wanted to compile, and not being from a computer science background, from my mechanical engineering background, with the engineering skills, and then picking up right from the basic software languages, and then getting into machine learning, I felt I brought a different perspective to machine learning. So I kind of it's not like a typical somebody who has done the degree in computer science and gone through it. I kind of brought more practicality. So I really wanted to share my unique perspective, and that is one of the main reasons. And then when I thought about it, I mean, it had been in back of my mind, but especially with my work at GE Transportation, with the work on the computer vision project, we really spent a lot of time trying to master a system to deploy intelligence to the field. And then that was something I really saw that, and especially at that time, things like Kubernetes was new. Kubeflow was, I think, Dave Aronchik had just released his first YouTube video on Kubernetes. It was that time, and so we didn't really have any tools. To be honest, after I got your invite, I went back to the book and checked. I have not mentioned MLOps in the book, though the book is called Keras to Kubernetes, Journey of a ML Model to Production. I don't call it MLOps because MLOps was not a word at that time. So,
Yeah.
I think that is what I wanted to share. That taking a model, taking this intelligence, putting it in production. What are some of the loops to go through? And like Vishnu, you said, I think I found at that time the two top technologies were Keras and Kubernetes. Everybody was building ML models in Keras, and everybody was trying to deploy models in Kubernetes. So I tried to do a best of both worlds. The half of the book talks about Keras, a lot of computer vision kind of models, and then uh, uh, building some ML models, even some text analytics models. And then second half is more around deployment. And the last couple of chapters, which are my favorite, are more my thoughts on how this scenario would change, how the ML deployment will change. And at that time, none of these MLOps standards were published. And I'm very happy to say, even if I read the book now, I mean, just yesterday I glanced over the last two chapters. I think most of the things are very relevant, even with the state of the art MLOps things that are happening today. I think a lot of the basics still remain the same,
Right.
and I think, yeah.
I think, so the book released in May 2019. And I have to say that a lot of the fundamental concepts that are, in the book, talking about like, well, what is it about machine learning that we should understand? Important concepts like bias variance trade-offs and how to develop models. How do you think about maturing your infrastructure, going from just a model to a container to then using containerization, software? It has that incremental component, very well laid out. That's embedded in the title, right? Keras to Kubernetes. What I am curious about is to say, okay, it's November 2022. O'Reilly comes to you and says, "Hey, Dattaraj, We love the first version of your book. We want version 2. We want it to go out in May 2023.
Mhm.
What's the title of that book that has the same message of how to go from problem to ML system, and what kinds of new content are you including?
Yeah,
And you can
that's
just kind of curious.
oh, that's a tough one, Vishnu. That's a great question. Um, but actually, I have thought about that. In fact, I did have a conversation, and I didn't want to do the second edition because unfortunately, though the title was catchy, Keras to Kubernetes, it was very tool based. I mean, I didn't want to make it tool. So one of the changes I would do is not make it so tooling based, because at that time when I wrote it, everybody was talking about it. I mean, Kubernetes was, I mean, there were like people were talking about Kubernetes as the technology. So I would rather focus on the patterns. And that's what actually, even at Persistent, when we talk to customers, we try to look at the common patterns that are there. Patterns like drift monitoring, explainability, interpretability, patterns around packaging models, validation, error analysis. So I would, definitely the book title, I would try to focus around ML patterns. In fact, Chip beat me to it. Her new book, ML System, Patterns of ML, which I love. I think she just released that book, and that's an amazing book. But that is the thing that I had in mind. Like if I was going to write a new book, I would focus more on the patterns. And just like I explained with that ML, remote monitoring example, I mean, the patterns have not changed back from the 2000s. You're still packaging intelligence, deploying intelligence, monitoring for drift, checking for bias. So all that remains the same. So I would do something, write something around the generic patterns, and then you can use Keras, PyTorch, whatever technology you want to use, or some low-code tool like H2O, PyCaret, or SageMaker to build some of these things. So even today, when at Persistent, when customers come to us for MLOps, we try to focus more around this pattern. Say that, okay, what is the problem you're trying to solve? What is the best pattern for you? And then that can be realized. I mean, if you want it to be done in SageMaker, Vertex AI, we can build it, or we can customize that particular tool to do it. But I would say, to answer your question, my next focus would be more around writing about the patterns and what are the best tools to realize these patterns, or even if those tools didn't exist, what I would visualize as the tools to realize some of these.
So, of course, I have to ask, and I love this that you're abstracting away from the tooling so that it is something that ages well, ages like a fine wine. And you can see, like in your book, as you were saying, it's Keras and Kubernetes. You didn't really mention MLOps. You didn't really go into it so much, and a lot of what is there, the essence of what is there that you're talking about, it lives on beyond Keras,
Yeah.
Kubernetes. Even if both of those end up not being useful in 20 years, the ideas that you propose in the book are still useful. So now, when it comes to those patterns that you're talking about, what are some of those? Like, can you go into more? You mentioned this. What is it? You mentioned
The
the type of bias you also
yeah.
mentioned, but like when I see when I think about patterns, I also think about, there is a great book out there, Machine Learning Design Patterns, that Lack put out, and a few other, Sarah and Mike, I think, are the other two authors. We'll throw it in the show notes in case anybody wants to know. But they talk about a lot about like the machine learning aspect. And there is some MLOps and maybe some deployment stuff in there, but I imagine you have the lens that you can look through and see what are a lot of these MLOps design patterns. What are things that you see over and over and you say, all right, this is, when you're
Yeah.
talking to customers, this is the pattern that you're going through. So in this case, these are things that you need to keep in mind.
Yeah, so some examples would be something around like, to start with, a data catalog. So you would want to not have your, I mean, I think everybody has moved out from the CSV, but even if have a data warehouse like Snowflake, you would want to have some cataloging mechanism, maybe DVC, or you have some version queries, or Snowflake has this time travel feature where you can go back in like for a period of time and pull data. So some way to catalog your data and publish it. I mean, a lot of people catalog it, but it is that catalog just remains with the coder. So you would want to have some system, even if though it looks mundane, but you would want to have a way to have your data versions published, and your data scientists have easy access to them. So that's one thing I think was very valuable. And on the similar lines, when the model is ready, a model registry. Now today, model registry is becoming very popular, and of course, like today, feature stores are also getting popular. And now there are like vector databases which do similarities, and I mean, those are also getting popular, especially with like Facebook has this FAS and Spotify has Annoy. Especially when you do recommendations, they really help you. But I think model registry is something I would. I see less. I would really love to see, because model registry becomes something like a model registry or catalog becomes like your basic, a foundation to your ML system. Like many customers I see, and we at Persistent, we have customers in different life cycle, right from somebody who are very new to ML to people building 100 models in production. So we see a lot of them not paying enough attention to having a very managed model registry and model governance. So I think because what that does is now you have a very organized catalog for your models, and the next step would be to look at patterns like deploying models as microservices, or what is getting popular today is ML as a service. So another pattern we also want to look at. So when we look at ML as a service, many customers are looking at monetizing those models, because because typically you look at ML model as, okay, you have a pickle file, and some developer will come and pull it, put it in an application and consume it. But that doesn't, especially these are very valuable models in the industry that I come from, banking and healthcare. These models are the ones making money for these customers. So they really want to monetize them. I mean, these are their major assets. They are trained from their data, and they can make much more money by cataloging this better, and even making them available as a marketplace. So today, some of the things that some customers are actually monetizing them. They have a token based system to actually invoke these models, like Amazon has, like your Amazon marketplace, a marketplace offering where they can charge customers based on usage of these models. Or even
That's so cool.
internally, they would want to have a better control of how these models are used, so they can manage the life cycle of this. So again, a long answer to your question, but I would say some things like model registry, data cataloging, the managing multi-tenancy. Many times customers have, if you have multiple customers for the same model, how do you do multi-tenancy? These are not some things that a data scientist would think of, but it is something that an ML engineer or an MLOps person should think of, and we should have. I mean, these are solved problems. We should have like a standard way to reuse these solutions. And then, like the earlier once I talked about bias and fairness. I mean, that is something you have libraries which can easily calculate that. But the key thing is you need to consider them. Many customers I've seen are like, they're hesitant to include them because they see bias as a like a negative thing, or they will get audited. But that is something you need to start incorporating. At least you need to have some audit reports, some model card of your model.
It's like we can't be biased if we don't audit it.
Yeah.
That's the, oh man, that is so interesting what you are talking about with the model registries, or just like the data scientists that are charging for their models or having that model marketplace, because I know that was something that Algorithmia was doing back
Yeah.
in the day.
Yeah,
And
exactly.
they ended up getting bought. And so I don't know if there are other companies or tools that have gone to market with that same approach, but it is a fascinating one to think about and to see uh, how others are tackling that problem. I also really like this idea around the multi-tenancy and managing multi-tenancy, because it is so difficult when it comes to security, right? And like what you need to get past the DevSecOps team, what you need to make sure
Yeah.
everything checks out. And if you're a data scientist trying to do that, it's a lot harder.
Yeah, exactly. In fact, it's interesting you mentioned about algorithmia. I spoke to Diego when we were building this platform. I mean, back before he went to, I think I should, Data Robot. Sorry, yeah. So he actually, we had an interesting discussion over email, but he was sharing some of his experiences. And the good thing is he actually made a lot of those papers public. I mean, the way behind the scenes how they were doing algorithmia. So I think yeah, that is one of the very popular. I mean, that's a prime example of a very popular pattern.
Yeah. So cool. They were ahead of their time.
Yep.
So, Dattaraj, man, this has been excellent. I cannot thank you enough. Super happy to have you on here and learn from you. You have so much wisdom, you have so much experience. And if anyone wants to get your book, they can go to O'Reilly, I think it is, or Amazon.
Yeah,
they'll have it there, and they can pick it up. It has aged well. There's some books that do not age well because they talk about how to do things in the step-by-step guide, and then as soon as the new package comes out or the new hot thing on the market comes out, then you recognize that all that you've learned from that book is no longer available or useful to you. This is not one of those books. This is a book that you will learn a ton from, even though it was written 3 years ago, over 3 years ago.
Yeah, 4 years ago.
Oh man, it's incredible. You did a great job, and I am so thankful to be able to speak with you and talk with you about all this cool stuff.
Thank you so much, Dimitri. Thank you, Vishnu. Thanks a lot. It was fun talking to you guys, and I love your podcast. Thanks. Keep up the great work.